कैमरा ऑन करो। सब लोग कैमरा ऑन करो। 1 2 3 4 12 people, so one is absent. Let me see who is absent. 13 12, so 2 people are absent. Beneath MTech mein Nitesh is there, Prashad is there, Vandana, Sahil. Okay. ठीक है. So let me directly go to the discussion, and maybe for 45 minutes we will have discussion on multi-degree of freedom, and then half an hour will be doubt clearing, half an hour or more. If you have doubt, if you don't have doubt, then we will not have any time. So take out your camera. I am directly going to the discussion page. एक मिनट, क्या हुआ? Now, just look at this last PPT. This was last page of, I think, Friday's discussion. Yeah, Friday's discussion. This was the last page where we stopped the iteration here. We stopped the iteration here, and I have given you the answer. Answer is actually 12, not 11.95. Actual answer is we will get 12 here. Inside we will get 1, 2, 0, 1, 0, which will finally give omega is equal to square root of k by m. Actual answer. But we stopped our iteration here. Now, if you have understood how matrix iteration works, then there should be, I'm expecting you should ask at least 4 or 5 questions on this method. If you have understood the method, then definitely 4 or 5 questions will come to your mind. What are those 4 or 5 questions? So let us discuss. This is not an easy method. It appears to be a simple and easy method, but this method triggers 4-5 questions in our mind. What are those 4-5 questions? Questions should come from you.
So what should be the starting vector? Should it always be 1, 1, 1?
Okay. Question number 2. I will answer all the question. This is a good question. What is question number 2?
So instead of iteration, we would have gone for eigenvalue equation.
Huh?
We should have gone for eigenvalue solution,
We are doing exactly that.
but we are finding through iteration.
And how do you find out eigenvalue otherwise?
Or through the formula you have given us for in MATLAB.
Oh, but how MATLAB finds it out?
It's through iteration.
No, definitely no. Definitely no. So we are discussing a method. Finally, whether you will do it yourself or you will take the help of MATLAB, that is another question. It is something like I have mobile, and through mobile I can, if you marry, your wife will directly answer that get the food through Swiggy and Zomato. Don't ask me. I have not learned how to cook. You are giving answer like that. Since MATLAB can find out eigenvalue, why I should learn the method to find out eigenvalue, isn't it? There are softwares who will help you, but it doesn't mean that you don't learn how to do it. So here we are discussing how to do it. I am not saying in real life you will follow this method. I am not saying that. But you should know what is the mathematical method. Otherwise, you will become a useless engineer. Question number 2. Question number 1 I have accepted. There should be many questions.
Sir, how many number of iterations to be performed?
Correct. Question, I accept it, I will answer it. Question 3.
So what are the other two natural frequencies?
What are the other two? Yes, how to get other two? Good question. So 3 questions people have asked.
And is this method always convergent, like we get the same answer?
Again speak out.
Is this method always converging to the answer?
Correct. This is a very good question. Question number 4. Let me, you should write down all these questions. You should, maybe your friend is asking the question, but you should write down all the questions because answer to all the questions are important. So question number 4 was, because if I forget, you will remind me that this is question number 4. Question number 4 is it necessary that all the time iteration will converge? That is question number 4. Question number 5. But before we go to question number 5, you write down question number 1 क्या था? What should be starting vector? Should it be always 1, 1, 1? Question number 1. Question number 2 क्या था? मैं भूल गया. अरे जिसने पूछा था उसको तो याद रहना चाहिए. क्वेश्चन नंबर
number of iterations.
Number of iteration. Question number 3.
Other two natural frequencies.
Other natural frequencies. Don't call it other two. In this case, the other two. For a bigger system, other. Question number 4 क्या था? Is it necessary? Okay. So let me first address these 4 questions. There can be few more. Answer to first one is 1, 1, 1 is not necessary. This is a common, but we can always start with another vector. It can be 1, 2, 3. But when I say we can start with another vector, the question number 4 becomes connected. We have seen that We started with 1, 1, 1, it converged. If we start with 1, 2, 3, will it converge? So why don't you check it? Why don't you check it? You do it yourself. You do the matrix iteration again, but not starting with 1, 1, 1, to start with 1, 2, 3. Let's see what happens. So let's learn it through experience, not from textbook. So all of you, I'm giving you 5 minutes. Do the iteration again, but now you take your starting vector 1, 2, 3. देखो क्या मिलता है. Our iteration matrix remains same, K inverse M. So iteration matrix remains 5, 3, 1, 3, 9, 3, 1, 3, 5. Anyone who can tell me what's happening if you start with 1, 2, 3?
So it's converging steadily.
So values are decreasing.
So answer to the question is that there is a proof that for even if we start with different vectors, it will always converge. Second statement is, which is even more important, it will always converge, but converge to the first lowest natural frequency only. It will always converge, but it will converge to the lowest natural frequency. So we don't have any doubt. Whatever natural frequency we get, we can call it omega 1. It is not omega 2, it is not omega 3, it is not omega 4. There is a proof. Proof I will come after the exam, not now. It will always converge is first sentence. Second is it will converge to the lowest eigenvalue or lowest natural frequency. There is a proof. How quickly it will converge or number of iteration, that may not be same. It depends on how close is the starting vector with the actual mode shape number 1. So what is actual mode shape number 1? 1, 2, 1. So if I take, say, 1, 2, 2, then I will see that is converging much faster because 1, 2, 2 is almost same as actual answer 1, 2, 1. So number of iteration will depend on how close is starting vector from the mode shape number 1. But now there is a problem. I don't know mode shape number 1. So whatever I choose, I really don't know how close it is. So this method is a blind method. I don't know mode shape number 1. So I don't know, should I choose 1, 1, 1? Should I choose 1, 2, 3? Should I choose 1, 2, 1? I really don't know. So when we don't know anything, it is a common practice. Start with 1, 1, 1. It is a common practice. Start with 1, 1, 1. Fine, when you don't know anything. However, in exam, you can start with 1, 10, 100 also. Only thing, number of iteration may be much more. So you have to be ready. How many iterations is needed? So 3 statements I have given. Yes, it will always converge. It will converge to the lowest natural frequency. How quickly it will converge, it depends on how close is the starting vector with respect to the answer or mode shape number 1, which we don't know. What other question I have not answered? I think एक दो question हमने answer नहीं किया. Yes, how to get other frequencies, that again we will see. Now see, since I am saying it will always converge to the lowest natural frequency, that statement triggers another question. If it always converges to lowest natural frequency, how can I get other natural frequencies? It's a very big question. It's a very big question. But can you tell me that as an engineer, do you think this gives you at least some achievement if matrix iteration method tells you, or if the mathematician tells you that here is a method which perhaps cannot give all natural frequencies, but it can definitely give you the lowest natural frequency. So as an engineer, do you think that you will feel some achievement कि नहीं कुछ तो हुआ है काम? Do you think so? or you will say नहीं नहीं इसका कोई मतलब ही नहीं है. It only gives us lowest natural frequency. It doesn't give us other natural frequency. So I don't care this method. What will be your approach?
It is an achievement because if the excitation frequency we can
अरे नहीं नहीं
circulate
नहीं
over
नहीं excitation frequency always need not be close to lowest natural frequency. कुछ और ढंग से जवाब देने का कोशिश. You should answer this question because we have had enough discussion last 2 months. सोचो. अरे भाई earthquake मैं बताया ना.
yes sir.
हाँ. Now, natural excitations like cyclone, earthquake, they have frequency range in the lower side. So, if at all the damage occurs, damage will not occur due to your third natural frequency or fourth natural frequency or 10th natural frequency. Damage will occur because your lowest natural frequency omega 1 or maybe omega 1 and omega 2 or maybe omega 1, omega 2, omega 3, they are in the danger zone. So, in any engineering system, an engineer never wants to find out all the natural frequencies. Whereas a mathematician, hopefully say, he will try to find out all the natural frequencies, but engineers will not. Engineers will say, no, for me, most important is omega 1, then omega 2, then omega 3. जैसे एक नेचुरल फ्रीक्वेंसी 33 हर्ट्ज के ऊपर चला जाएगा, he will stop focusing other natural frequencies because they are not going to create danger. So please remember that if matrix iteration can give us omega 1, it's an achievement. After exam, I'll show you that we can not only find out omega 1, we can find out omega 2 also. We can find out omega 3 also. But lot of mathematical technique we need for that. But I am proceeding. Today, my focus is how to get lowest natural frequency using matrix iteration method. Fine. Now, suppose my starting vector is 1, 0, minus 1. क्या होगा? देखो. Suppose मैं सोचा रहे चलो थोड़ा नेगेटिव भी डालते हैं. 1, 0, minus 1. If that is my starting vector, what will happen? हाँ बोलो. क्या हो रहा? Suppose my starting vector is 1, 0, minus 1.
is increasing positively, minus 1 increasing decreasing negatively.
नहीं.
Sir, we are getting again 1, 0, minus 1.
That is the correct answer. Iteration is not proceeding at all. Iteration is not proceeding at all. Can anybody explain this? And are you getting lowest natural frequency? Answer is no. So this is a very peculiar case. Just 5 minutes before I said, whatever may be starting vector, iteration will always converge to the lowest natural frequency. Is it happening in this case? It is not happening in this case. So how do you explain it? Answer is very simple. Answer is very, very ordinary.
It is giving another natural frequency.
So I must modify my sentence that whatever is the starting vector, it will always converge to the first natural frequency. That sentence is not correct every time. I should modify that sentence. Except when starting vector happens to be exactly other mode shapes. So whatever you have written that first sentence, now you add another sentence. Except when starting vector happens to be exactly same as higher mode shapes. So in this case, the iteration did not proceed because 1, 0, minus 1 happened to be second mode shape. So you check with another starting vector 1 minus 1 1 क्या होता है? Suppose I select 1 minus 1 1 क्या होगा?
-1 1 1.
No, क्या होगा मैंने पूछा. I am not asking the numerical answer.
I am asking a starting vector.
Oh, starting vector. I said 1 minus 1 1.
So we get
Same thing will happen again.
1 minus 1.
Why same thing is happening? So this is my third mode shape.
Yes.
1 0 minus 1 was my second mode shape. This is my third mode shape. Why I am saying 1 0 minus 1 was second mode shape and 1 minus 1 1 is third mode shape? Can you tell me? On what basis I am saying? I am able to understand कि O वाला second mode shape है और A वाला third mode shape है.
So based on value of natural frequency.
Correct. In this case, the value of natural frequency is higher than the previous case. That is one technique. There is another technique. Can anybody guess it? You should know. Your intuition has to be there. Then only you become engineer. हमारे देश में almost 1 lakh students are getting engineering degree. More than 1 lakh. Out of them, hardly 100 students should be called engineer. बाकी सब बेकार है. हाँ बताओ. Second mode shape, we started with 1 0 minus 1. We found the iteration is getting locked. So this is a mode shape. We started with 1 minus 1 1. Again the iteration is getting locked. So this is a mode shape. Now if you look at these two mode shapes, do you think there is another method to identify that this is second mode shape and this is third mode shape and this is first mode shape? Now look at all the three mode shapes. Now you know all the three mode shapes. I have given all the three exact answer of the mode shapes. 1 2 1, mode shape number 1. 1 0 minus 1, second mode shape. 1 minus 1 1 third mode shape. Now looking at these three mode shapes, कुछ दिमाग में आ रहा, कुछ दिखता है? Do you see anything interesting? First mode shape, second mode shape, third mode shape. Anything interesting?
Satisfying the equation of
Yeah, orthogonal.
Okay, that is a very good observation. They are orthogonal. This statement I have not given. We will prove it. That mode shapes are always orthogonal to each other. But this is not simple orthogonality. Orthogonal with respect to both mass matrix and K matrix. It is a very good observation, but this is not the answer I'm looking for. We'll come to orthogonality again after the exam. But I'm looking something else. Easy. You look at all the three mode shapes. Okay, I should not waste time. Number of sign change. Look at number of sign change. So there is another theorem. Number of sign change is 1 less than the order of the mode shape. Number of sign change will be 1 less than the order of the mode shape. So if it is third mode shape, there will be 2 sign change. If it is second mode shape, there will be 1 sign change. And if it is first mode shape, there will not be any sign change. Now, all these observations or all these sentences, they are never written in any textbook of the world, unfortunately. But these are very important statements. अब कोई मुझे बता सकता है अभी कि just now I have made some additional mathematical statements. Mode shapes are orthogonal, we'll use it. It's a very powerful statement. Mode shapes are orthogonal. We need this statement after the exam. We will not discuss it today. But my second statement, let me pick it up again. That number of sign changes can help us to know the order of the mode shape. Because number of sign changes will be always 1 less than order of the mode shape. Therefore, 1, 0, minus 1, it has to be second mode shape. If at all it is a mode shape, it has to be second mode shape. It has to be second mode shape. It cannot be first mode shape. It cannot be third mode shape. If 1 minus 1, 1 happens to be a mode shape, immediately I can say this is second mode shape. Now, this is also an important statement. This statement is helping me, but in what manner? Can you tell me why I am calling this is helping me? In what way it can help us?
Well, it will help us
Starting
in
vector.
taking starting vector, so that
Correct.
if you want second or
No. Bolo. Let me not stop you. Bolo, continue.
just
If you
let's
want-
say if you take a starting vector 1, 1 minus 1, it will lead toward the second Mohr shape.
No.
So,
What was my statement little before? Iteration will always converge to the first mode shape, except when it is exactly equal to higher mode shape. So 1, 1 minus 1 will also converge to first mode shape. You can start. You will see, very interesting. 1, 1 minus 1, if you start, it will also converge to first mode shape. So that sentence you have to understand. Your starting vector can have a sign change. Your starting vector can have a sign change. It doesn't mean it has one sign change, so it will converge to second mode shape. No. If it has 2 sign change, it will converge to third mode shape. No. unless and until it is exactly equal to the second mode shape or third mode shape, whatever may be your starting vector, it will always converge to first mode shape. It's a beautiful property, and there is a mathematical proof. I will come to the proof, but all these mathematics I will do after the exam, not now. But these observations you must have right now. So if you start with 1, 1, minus 1, it will not converge to second mode shape. It will converge to first mode shape. Okay, but my question remains open. Try to answer it. How it can help us? सोचो सोचो, सोचना बहुत जरूरी है. So whatever I have been discussing last 5 or 10 minutes, it definitely helped me to select the starting vector. So what do we learn from it? Even if there is a sign change in the starting vector, we should not prefer it. We should prefer a starting vector having no sign change. अब बताओ 1 1 1 और 1 1 minus 1 दोनों ही कन्वर्ज करेगा, तो फिर मुझे किसको सिलेक्ट करना चाहिए?
1 1 1
क्यों? Why?
is more close towards the
Correct.
first mode.
It is closer. So the moment you go for a sign change, still it may close, it may converge, but sign change मतलब it is much away from the first mode shape. क्योंकि हमें मालूम है फर्स्ट मोड शेप में साइन चेंज नहीं होना चाहिए. So if I pick up a starting vector with a sign change, it is at a much distance from the starting vector. So number of iteration will be more. Why unnecessarily I should have more number of sign change, more number of iteration knowingly? So we should always pick up starting vector having no sign change, all positive. And it's a common practice, 1 1 1. Now, whatever we have discussed, anything coming anybody's mind, you can ask me. My discussion is not over, but before I take it forward, जितना भी discussion हुआ, they are very, very powerful discussion. I mean, my last 40 minutes discussion should be recorded for any student in the world, because this is not discussed in textbook.
Sir, so we will start with any vector and we get the first mode shape, but how do we know that what are second and third mode shape?
I have said, I have accepted the question and I have kept it pending after the exam. I said that question is good. Today we focus on first mode shape, but after exam हम धीरे धीरे हम second mode shape भी ढूंढ के निकालेंगे. See, engineers cannot say no. We will find out second mode shape also. We will find out third mode shape also. अब बताओ, तुम में से कोई अगर पुलिस बनता, तो how do you crack a criminal case, Shrabha? Are you fond of detective novels?
Yes, sir.
अरे.
For profiling.
Have you heard of Sherlock Holmes?
Yes, sir.
Yes, sir.
नहीं, मैं Shrabha को पूछ रहा.
Yes, sir.
Name a single Sherlock Holmes detective story.
Sir, I have read it long back. I don't remember.
यही तो हो गया. इंटरव्यू में ऐसा भी पूछा जाता है. Hound of the Baskerville. Anyway, ठीक है. But I always ask my students to go through 2 novels. One is Sherlock Holmes Omnibus, where all the detective story written by Arthur Conan Doyle. Second is Day of the Jackal. Day of the Jackal is Frederick Forsyth, written in 1973 or 72, and there has been a movie also. I always ask that if you want to become engineer, first you study these two books and then start studying solid mechanics, mathematics and other things. Anyway, why I ask students to go through Sherlock Holmes Sherlock Holmes novels or stories? Can anybody guess? कि टीचर को खुद को ना पढ़ाना पड़े, है ना? Why?
So the possibility of the cases we can find.
See, if you go through a Sherlock Holmes story in English, not in your mother tongue, two things are very important. One is English, fantastic English. You learn how to frame an English sentence. You really learn it. Second is Sherlock Holmes story, they shows us the logical deduction, how Sherlock Holmes arrives at the criminal, step-by-step logical procedure. So beautiful logical procedure. And mathematics also, engineering also is based on logical procedure. There has to be step-by-step logistics. Generally, it is missing in our teaching. See, little before, it was called Nitesh Kumar, MTech. He told me, sir, MATLAB में तो आइगन वैल्यू मिल जाएगा, फालतू का हम क्यों मैट्रिक्स इटरेशन की बात करेंगे? ऐसा ही क्वेश्चन था ना तुम्हारा, नितेश?
सर
नहीं, ठीक है. अब हम लास्ट 40 मिनट्स में हमने क्या सीखा कि not only you learned how to find out the natural frequency, but in the process you learned so many things which MATLAB will never tell you. Agree? MATLAB सीधा बता देगा, this is natural frequency number 1, this is natural frequency number 2, this is natural frequency number 3. MATLAB will never tell you कि मोड शेप में साइन चेंज कैसे होता है, कितना होता है. MATLAB will not tell you. So, if you really go through Sherlock Holmes, you will see he proceeds step by step. Generally, even today, how police generally cracks a criminal case, मालूम है? पुलिस कैसे क्रैक करता है nowadays? They try to get at least one of the culprit. अब उसको पकड़ के उससे पूछताछ चलता है, इंटरोगेशन चलता है. फिर बेस्ड ऑन इंटरोगेशन ऑफ द फर्स्ट कल्प्रिट दे कैच द सेकेंड कल्प्रिट. उसको भी पकड़ के लाता, इंटरोगेशन चलता है. देन दे कैच द थर्ड कल्प्रिट. दिस इज हाउ पुलिस क्रैक्स एनी क्रिमिनल केस. सेम थिंग वी डू व्हेन वी वांट टू फाइंड आउट नेचुरल फ्रीक्वेंसीज. We first find out first natural frequency and first mode shape. After the exam, we'll discuss कि हम first natural frequency, first mode shape को utilize करके, then we will catch the second mode shape and second natural frequency. There is a beautiful mathematics. फिर second जब मिल जाएगा, फिर हम third में जाएंगे. So there is a concept of sweeping matrix. I'll talk about it, but after the exam. So second and third also we can find out. It's not that we are helpless, but as I'm saying, today my focus is first natural frequency and first mode shape. Any question? किसी का मन में आ रहा in this discussion?
Sir, why will there be no change in the sign in first matrix? That is not clear. Why is there no sign change in the first matrix?
First mode shape.
Yes, sir.
No. So they have their own mathematics. These answers will come later on. I agree. Today I am giving you the picture. But are you having any other interesting features which I have not presented? I am trying to show you something interesting, and not only something interesting, I am also telling you how it can be helpful to us. और कोई इंटरेस्टिंग चीज देखे आज नजर में आया?
I have a imaginary situation. Can you ask?
हाँ, बोलो.
Let's say excitation frequency. We are taking two situations. in first situation, excitation frequency resonates with omega 1. In second situation, it resonates with omega 2. In which case the damage is more?
That is another. We have to find out FRF, frequency response function. But this is a very, I'm accepting this question that little before I said that as an engineer, we generally try to give focus to lowest natural frequency. For example, if it is earthquake, if it is cyclone, definitely lowest natural frequency, I am saying more important, doesn't mean that resonance at omega 1 will be more dangerous than resonance at omega 2. You go back to response spectrum graph. Okay, I'll give you the answer a little bit. If you go back to response spectrum graph, suppose your omega 1 is on the very, very lower side. You will see that your response spectrum amplitude is not that much. Whereas little later, response spectrum amplitude goes up. And there comes omega 2. Then omega 2 will be more dangerous than omega 1 for earthquake. So which resonance will be more dangerous? It depends on two things: where the natural frequencies are and what is the spectrum of excitation. It depends on both. And it may happen that omega 2 can become more dangerous than omega 1. It can happen. Definitely it can happen. I'll give another example. We have a horizontal beam. At the middle there is a machine, and machine has an unbalance. Machine is rotating at 1470 RPM, which means roughly 24.5 Hertz. Now suppose in the beam, omega 1 is 10 Hertz and omega 2 is 24 Hertz. So it is the omega 2 which will come into resonance, not omega 1. So omega 2, I mean, you calculated omega 1 and then you didn't try to calculate omega 2 thinking, अरे चलो भाई बहुत हो गया. नहीं, हमें ओमेगा 2 कैलकुलेट करके देखना चाहिए वो एक्साइटेशन फ्रीक्वेंसी के पास. This is harmonic excitation. This is not natural excitation. What is the difference between machine excitation and natural excitation? Machine excitation happens generally at single frequency or few harmonics of the single frequency. But natural excitation happens in a wide band. This is called wide band excitation. So if it is unbalanced, then my excitation will not have 10 Hertz, 12 Hertz, 13 Hertz. It will have only one frequency, that is the frequency of rotation, 24.5. Now my beam may not have omega 1 close to 24.5. It may have omega 3 close to 24.5. So I have to calculate third natural frequency also. But so let's not generalize कि सिर्फ lowest natural frequency is everything. What we say, the few natural frequencies on the lower side, that's all. It can be first and second, it can be first, second, third, it can be first, second, third, fourth. But we don't try to find out the highest natural frequency. Suppose there are 10 natural frequency. We don't start our focus on 10th frequency or 9th frequency. We always start our focus from first, then second, then third. Any other observation?
From this one more question arises.
And you can ask 5 more questions.
Okay, sir. As you said, let be natural frequency be 20 Hertz and 24 Hertz. And what two situation? If excitation frequency is 23 and second situation excitation frequency.
No, that answer I have already given. No, that answer I have already given. Which one will be more dangerous will depend on FRA, frequency response function, that we will calculate again after. See, this multi-degree of freedom will take roughly 10 lectures. I think I have mentioned in last class. It's a huge chapter.
Yes, sir.
So wait for that. Definitely I will answer it. I will not run away from it because it's a good question.
Okay, sir.
आज का डिस्कशन में और क्या क्या चीज आ रहा है. Today our focus is on first natural frequency. Adari Nandana has observed a very important thing. Mode shapes are orthogonal. It's a very good observation, because using this orthogonality property, we will find out second mode shape, second natural frequency, third mode shape, third natural frequency, but after the exam. आज हम जो चर्चा किया उसके ऊपर बताओ, आप किसी को कुछ दिमाग में आ रहा?
Sir, I have a doubt, sir. For semi-definite system, the first natural frequency will
Zero.
be zero, no? So how will we get to the other natural frequencies, sir, then? Like other mode shapes?
No, semi-natural. So we have not picked up any example of semi-definite matrix now. Agree? ये जो matrix है. So I will take a semi-definite matrix also. How will you know that this is semi-definite? कैसे पता चलेगा? उसके it will become a singular matrix. It will become a singular matrix. So 1 omega comes out to be 0. So उसको, that means for semi-definite matrix, omega 1 has to be 0. We have to know how to find out omega 2, omega 3, omega 4 like that. So that is higher natural frequency. तो वही चीज हम चर्चा करेंगे. We will discuss it for this case also, how to find out higher natural frequency. Today we are focusing only on the lowest natural frequency. Semi-definite system, the moment matrix K inverse M becomes singular, we don't try to find out natural frequency, because we know it is singular because its lowest natural frequency is 0. So let me give you a 10 minutes problem. You have noted in earthquake, we started with a single story building. याद आ रहा कुछ? For a single story building, total stiffness of the column was K, mass of the slab was M. So there was only one natural frequency, and that only one natural frequency was square root of K by N. You remember or you forgot? Remember. And whatever numerical value I have given, square root K by M is coming 31 point something, and our conclusion was this building is more or less safe. Then what we have done? We added one more story. We solved that also. We found that now we have two natural frequency, and the lowest natural frequency is somewhere around 19 hertz. Now my question is, suppose I go for 3-story building. जल्दी से मुझे आंसर बताओ, लोएस्ट नेचुरल फ्रीक्वेंसी कितना होगा? This is a possible exam question. So time will give me an idea. I have explained the problem. Let us go for a 3-story building. K same, M same. K remains same. M remains same. मतलब M1 is equal to M2 is equal to M3 is equal to M. K1 is equal to K2 is equal to K3 is equal to K. You write down the differential equation, draw the figure. Question is like that. First draw the figure. I'll give you 15 minutes time, don't worry. Draw the figure. Write down the equations. Obtain mass matrix and K matrix. Go for K inverse and obtain the iteration matrix. Once you obtain the iteration matrix, start your iteration. And finally you tell me this is my lowest natural frequency. Karo. I'll give you 15 minutes. Aram se karo. This is a exam level question. So you have to be ready for 15 minutes only, not more than 15 minutes. 3-story building. Draw the picture, write down the equations, obtain K matrix, mass matrix, then obtain K inverse M matrix, that is your iteration matrix. Start iteration. Take roughly 4-5 iteration. Convergence आ जाएगा. Anyone who has got the iteration matrix?
Yes, sir.
क्या मिला Binit? Iteration matrix?
So it's 1, 1, 1, 1, 2, 2, 1, 2, 3.
That is correct. Go ahead.
So got the final answer.
क्या मिला?
So 1, 1.8, 2.24.
No, natural frequency.
Oh, no, no. Yeah, sorry.
Lowest natural frequency.
So 449 radians per second.
अरे हर्ट्स में बोलो, हम अर्थक्वेक की बात कर रहे हैं हर्ट्स में.
So 71 hertz.
हाँ
71 hertz I got.
71 हर्ट्स तो गलत है. इतना टाइम नहीं लगना चाहिए. Again and again I am saying, you should do lot of practice how to find out inverse of a matrix. अब थर्ड ईयर में आके सिखाना पड़ेगा क्या?
Sir, is it 14.24 hertz?
किसने बोला? प्रणव.
Prasad.
That is correct. That is correct. Your answer is under root k by m के बाहर कितना मिला?
Sir, actually I had omega square had done that.
Omega square कितना मिला?
Sir, omega square came out to be 8006.405.
अरे यार फिर before putting the numerical value of k and m.
Okay, sir. 4.996.
Again, you are making a mistake.
So 5.04.
Omega square कितना?
Sir, omega square is 0.2 multiplied by k by m.
Correct. 0.2 square root k by m. That is correct answer. ठीक है. So that is the correct answer, and because the natural frequency is coming out to be 14 hertz, इसका मतलब it is more dangerous. It is more dangerous. If you look at the response spectrum, you will see 14.5 or 7 hertz is more dangerous than two-story building, that is 19 hertz. So single-story building was far better. As we raise the story, we enter into problem. But we are saying all this thing after we could calculate lowest natural frequency. So we have had extensive discussion on how to find out lowest natural frequency and first mode set using matrix iteration method. However, this is not enough. We should find out other natural frequencies and other mode shapes also. But that I will take up after the midterm exam. Now, another 15 minutes. Any other doubt in any other chapter, you can ask me. So there you may expect a question from multi-degree of freedom. Okay? You may expect a question from multi-degree of freedom. So this 3-story building, if it comes in exam, you will get only 15 minutes. So unless and until you practice, time will be a problem in exam. That I can tell you. Don't blame me. Time will be a problem. So you should have mathematical practice. हाँ, किसी को और कुछ डाउट है तो बोलो. कोई भी चैप्टर के ऊपर, कोई भी any other area.
So,
or in general, हाँ बोलो.
while you writing equation from Lagrange's, what are the generalized forces?
No, if you remember that Lagrange equation I have used for free vibration, means whatever problems I have given a problem set. If you look at the problems, all are free vibration problems. Force is absent. So as far as exam is concerned, I will not bring force into picture. Because if I bring force into picture, then your question comes into action. How to write down generalized force. That comes from energy. That comes from energy. Okay. So if you want after the exam, I can discuss. But my intention was just to make the equation so that we can find out natural frequencies. So all my problems in the problem set, if you look at it, force was absent. So you don't need to find out generalized force there. As such, whatever I have discussed, two things I have not considered. One is damping. In Lagrange equation also, how to bring in damping. So I have mentioned that we don't bring in damping in the original equation of motion. We bring, and in multi-degree of freedom, we'll discuss it again. If you remember this building design or whatever equations you derive today, single story, double story, multi-story building, in our mathematical model, damping was absent. Why? Does it mean damping is unnecessary? Answer is no, damping is necessary. But we cannot bring damping in the starting. We will bring damping later on. So because of that concept, in Lagrange equation, we don't try to look for damping. So we keep damping absent, we keep generalized forces also absent. We bring them later on, not in the beginning. In the beginning, we look for the simple equations having stiffness and mass. Damping, we don't bring in the beginning, and forces also. Forces we don't need to calculate natural frequencies. To calculate natural frequencies, we never require forces. और कुछ पूछना है पूछो. I mean, I just want to know from you, are you finding this subject very tough, very difficult? I mean, what is the problem happening with you as far as this subject is concerned? I mean, where you are finding the difficulties? अरे इसमें भी जवाब नहीं. As if you people are expert. Huh?
No, sir, no problem. We are just lagging behind the practice.
No problem. लेकिन मैं जब अपना मार्क्स देखो, क्लास टेस्ट नंबर 1, क्लास टेस्ट नंबर 2, marks not showing. So where the things are becoming difficult, let me have a feedback कि ऐसा क्यों हो रहा. And you also should be interested to, find out the answer. ऐसा नहीं चलेगा. अभी तक सिर्फ 2 क्लास टेस्ट हुआ. Maybe around 20 marks class test. Mid-semester exam will be 25 marks. And you should be ready. In mid-semester exam, you should be ready for around 5 questions. उसमें एक लंबा होगा. And let me give you some idea about the mid-semester question papers. All questions will not be of same marks. If a question is lengthy, for example, suppose I ask you a question on matrix iteration method, तो कितना समय होना चाहिए? How much time I have indicated from my side? 15 minutes. So if a question time required is 15 minutes, I will give 6 marks for it because total 1 hour exam is 25 marks. ठीक है? But if a problem can be solved in 10 minutes, उसको कितना देंगे? 4 marks देंगे. And if a problem can be solved in, say, 6 minutes or 7 minutes, उसको 3 marks देंगे. 5 minutes, उसको 2 marks देंगे. So accordingly, I decide the marks. All problems will not have same amount of marks. छोटा प्रॉब्लम 2 मार्क्स, थोड़ा बड़ा 4 मार्क्स, और बड़ा 6 मार्क्स. Fine. So that is how there will be 5 problems, but need not be 5 into 5 is equal to 25. One problem may be bigger, other problem may be simpler. and don't try to write down unnecessary things, and don't try to go for derivation unless and until you have been asked. Okay, so don't try to go for derivation unless and until you have been asked that derive this. और क्या पूछना है पूछो, 5 मिनट है.
Sir, note for steps up in torsional.
Note for
Steps up.
the torsional oscillation.
Yes, sir. Torsional.
I have not given any note.
Sir, for simple shaft you have given.
हाँ तो फिर अरे यही तो हो गया ना. यू आर गोइंग टू बी इंजीनियर. हाँ, स्टेप सैप्ट का थ्योरी तो हमने एक्सप्लेन किया. आई रिमेम्बर आई सेड दैट स्टिफनेस आर पैरेलल, so you have to combine the stiffness. That I have discussed. Maybe for every discussion I may not have PPT. Remember that. For every, and that's why I'm saying that whenever I'm speaking out something, you must make it a habit to write down as a class note. I have discussed step set. ऐसा नहीं कि मैंने discuss नहीं किया. I have discussed in the class. Maybe in my PPT that was absent. So everything may not be there in PPT. So whatever is not there in PPT, you should have a class note because I have discussed. I have also discussed in a step set how to locate the node. It's tricky. And that is why listening each and every sentences that I speak during the class, it is very, very important. If you think that, I generally think, you may agree, you may disagree, that I teach much more than whatever is available in textbook. That much I believe. I don't know whether I'm correct or not. I discuss things, even those things which are never discussed in textbook. So you have to write down the class note. That is important. If you wait कि अरे PPT में तो मिल जाएगा, textbook में मिल जाएगा, then you may not get it. Steps up. हाँ बोलो, अगर doubt है तो बोलो steps up में.
You told us to try to find out, but I tried, but
so I do you think is it you are blaming कि why I asked you try to find out? Should I not expect this? No. Should I not expect this much from my student that they can try and they will be successful?
No, sir.
तो प्रॉब्लम कहाँ पे है? क्या हुआ? प्रॉब्लम बताओ, अपना प्रॉब्लम बताओ. कौन सा प्रॉब्लम में आंसर नहीं आया वो बोलो.
In the torsional PPT, it was 8th question.
8th question.
Yes, sir.
I know. उसमें नोट निकालना था, बराबर है.
Yes, sir.
So that is a exam question. उसको आज हम क्यों एग्जाम में डालेंगे नहीं, but that is the question I generally ask in exam. Yes, क्लास में उसका डिस्कशन हुआ था. I remember. दोनों सैप को सिंगल डायमीटर में ले आओ. दोनों डायमीटर क्या क्या है बताओ.
15 mm, 20 mm.
ठीक है. अब 15 mm और 20 mm में अभी दोनों को इक्विवेलेंट डायमीटर या तो 20 करो या तो 15 करो. ठीक है.
Yes, sir.
अच्छा, 20 करोगे तो लेंथ छोटा हो जाएगा कि लेंथ बढ़ जाएगा.
15 mm will be less length. 15 to 20, then it will be.
No. What I'm saying, you have a combination of 15 mm shaft with 20 mm shaft. Now you convert it into an equivalent shaft जिसका diameter constant diameter है, तो उसका लेंथ बदल जाएगा ना अभी.
Yes, sir.
अभी लेंथ 150 and 150 300 नहीं होगा.
Yes, sir.
तो 20 करोगे तो कुछ लेंथ मिलेंगे, 150 करोगे तो कुछ लेंथ मिलेगा, ठीक है। सो यू कन्वर्ट इट इनटू यूनिफॉर्म डाया सैप्ट, उसका तो नोड निकल जाएगा।
यस सर।
हाँ, अभी उसका नोड जहां पे आएगा उसमें 20 तक तो जितना लंबाई था उसको छोड़ के बाकी जगह को मैनिपुलेट कर। फॉर एग्जाम्पल, सपोज लोकेशन ऑफ द नोड कम्स आउट टू बी 200 मिलीमीटर सपोज, तो 150 तो हमारा 20 मिलीमीटर सैप्ट में था ही, तो इसका मतलब 20 मिलीमीटर सैप्ट खत्म होने के बाद और 50 मिलीमीटर दूरी में नोड आ रहा है, लेकिन वो 50 मिलीमीटर दूरी में जो नोड आ रहा है वो 20 मिलीमीटर सैप्ट का हिसाब से, हमारा तो वहां पे एक्चुअल डायग्राम में वहां पे 15 मिलीमीटर सैप्ट है।
यस सर।
तो दिस 50 millimeter distance on 20 millimeter sapt will be equivalent to something else on 15 millimeter sapt। वो something else मिल जाएगा तो actual location of node निकल जाएगा। समझ में आया अभी?
यस सर।
हाँ, so this is the problem. The moment we make the question little difficult, anyway, ठीक है, but I think I have explained it. Any other question from anybody? So I can close discussion. आज हम कोई नया पीपीटी नहीं भेज रहे हैं because I did not use any new PPT. But before I end, one question nobody asked me. It should have been asked today. हाँ, अच्छा, किसी को कुछ पूछना है तो बोलो। I think somebody was trying to ask a question.
Yes sir, one more question. In assignment 5 question
बोलो। हाँ, बोलो। क्वेश्चन क्या है बोलो।
It was a sensitive instrument of mass 130.
अरे no, एक मिनट नितेश कुमार, now you don't try to get all problems solved by me.
No sir, I don't want the answer, but I want to discuss this question because it not seems logically correct.
बोलो क्वेश्चन पढ़ो।
A sensitive instrument of mass 113 kg is to be installed at a location where the vibration acceleration is 15.24 centimeter per second square at a frequency of 20 Hz. It is proposed to mount the instrument on a rubber pad with K equal to 2802 Newton per centimeter and zeta equal to 0.1, and watt acceleration is transmitted to the instrument.
Correct. So what is wrong with the question? You are saying logically not correct. What is that?
Sir, as we compare force by force.
No, is it motion transmissibility or force transmissibility?
Watt acceleration is transmitted.
No. I know. I have understood the question. I am asking you back.
Yes.
Do you think it is a problem on motion transmissibility or it is a problem on force transmissibility?
Force transmissibility.
No. It is a problem of motion transmissibility. Even then, the problem is difficult because in motion transmissibility, we compare the ratio of displacement magnitude. And in this problem, I am asking the ratio of amplitude magnitude. So question is correct and question is intelligent. It is motion transmissibility. It is not force transmissibility because I am asking you acceleration. I am not asking you how much force is getting transmitted. I am asking how much acceleration is getting transmitted. It is a motion transmissibility. However, in motion transmissibility, I have never discussed the ratio of input acceleration and output acceleration. I have not discussed. But not that everything I should discuss in the class. Something you have to innovate yourself. And this is a problem where you have to find out the formula for acceleration ratio. And if you can find out the formula for acceleration ratio, this problem is very, very easy. It is a tricky question again. And all the tricky question I am not going to answer. Okay, I can at the most give you a
I
hint.
get the gist.
And this is not force transmissibility, this is motion transmissibility. ठीक है? In motion transmissibility we find out the ratio x by y और y by x. यहाँ पे हमें y डबल डॉट पाई x डबल डॉट उनका रेशियो निकालना पड़ेगा. ठीक है? आई एम गिविंग यू हिंट. हिंट ही देंगे, पूरा नहीं बताएंगे. Okay.
Sir, I can able to find it.
No, you will be able. Anyway, so before we end up, one question nobody asked me, and one should have asked, and that was discussed in the last class. That matrix iteration method, we want to find out lowest natural frequency, and what is the only tough thing in that? If I ask you to find out lowest natural frequency using matrix iteration method, what is the toughest part of, I mean, where you need little more time? Can you tell me? Which one you are slightly uncomfortable? Admit it.
Finding the iteration matrix.
No. Find out the inverse of K matrix. Agree?
Yes, sir.
Yes,
I
sir.
know. I mean, let's not hide our discomfort. I know. We are really not happy when we are asked finding out inverse of matrix. Nobody asked me why you are not trying to, I mean, what will happen? I mean, can we have a matrix iteration method based on mass inverse? You just try. Suppose I ask you, can you suggest a matrix iteration method where instead of K inverse, we take mass inverse? You just see, you try it. Dekho. I mean, can we create an iteration matrix where we don't take inverse of K, we take inverse of M? देखो करके देखो. Can we create an iteration matrix? ऐसा संभव है क्या? See, these are the things which you people should think. सिर्फ क्लास में आके बैठ जाएंगे, टीचर सब कुछ बताएगा, and you never become an engineer. You become a mechanic. कोशिश करके देखो. Do you think another iteration matrix is possible where instead of taking inverse of K, we take inverse of mass matrix? ऐसा हो सकता क्या? I mean, I thought that I will ask this question in mid-semester exam. By mistake, I am asking it right now. तो चलो जा, एग्जाम में और कुछ डालेंगे, लेकिन इसका जवाब देना पड़ेगा. Do you think because we are more comfortable with inverse of mass matrix, we can create another iteration procedure where M inverse is needed, not K inverse? ऐसा हो सकता क्या? सब लोग चुपचाप क्यों है? सिंपल क्वेश्चन, वेरी ऑर्डिनरी क्वेश्चन. In matrix iteration method, what is our iteration matrix? It is K inverse M. Do you think we can have another iteration starting with M inverse K?
Yes, sir.
So what will be the full form?
M inverse K by omega square into X vector.
No. M inverse K into X vector will be omega square into X vector.
Yes, sir.
Am I correct?
Yes, sir.
So do you think even the way we did our iteration with K inverse M, we can as well do iteration in this manner also? That nobody asked me a question. Because this M inverse K will be 2 second, not 2 second, 1 minute job. Which one you will be able to find easily, M inverse K or K inverse M?
M inverse.
तो M inverse K में क्या गलती था? हमने M inverse K को तो चुना नहीं. Suppose now I prove that M inverse K into X is equal to omega square into X. Will it not converge? Answer is it will also converge. Answer is if we start iteration, it will also converge. But if it also converges, तो हम फालतू का K inverse M क्यों किया? M inverse K क्यों नहीं किया? Answer is very ordinary. Mentos लेना पड़ेगा. You need Mentos. ऐसा क्यों किया हमने M inverse K को क्यों नहीं चुना? K inverse M क्यों चुना? To harass the student? What is the answer? If you start your iteration with M inverse K, surprisingly you will see even that is also converging. So that is also a valid iteration procedure. Nothing wrong. तो फिर हमने M inverse K की चर्चा क्यों नहीं किया? My question, $1 million question. Who will answer it? Let me
The
see.
natural frequency is always comes root over K upon M.
अरे भाई उसको पलट देंगे तो फिर K by M आएगा ना. उधर भी M inverse K है. देखो ओमेगा स्क्वायर राइट हैंड साइड में है, लेफ्ट हैंड साइड में K by M आएगा. आंसर में कोई गड़बड़ नहीं आएगा. M inverse K है ना, तो लेफ्ट हैंड साइड में K by M आएगा, राइट हैंड साइड में ओमेगा स्क्वायर आएगा.
Yes.
उसमें कोई गड़बड़ नहीं है. But why I have not suggested M inverse K iteration? I have suggested K inverse M iteration.
Sir, generally we know the mass of the system, but not the K.
Then what did you say?
Sir, we know generally M, but not K.
Who says? We cannot do the iteration if we don't know stiffness also. Stiffness का value भी मालूम है ना हमारे पास. We need both. But mathematical procedure, which one will be easier? M inverse K or K inverse M? Obviously M inverse K. Then why I did not suggest a matrix iteration? Because this also converges. We can prove. There is a proof. There is a proof. All these things will come after exam, but there is a proof that M inverse K iteration will also converge. लेकिन हमने इसकी चर्चा क्यों नहीं किया? Let me see. Who is intelligent enough? You have to guess. Answer is very, very easy. You have to guess it. You have to catch the answer. ऐसा क्यों नहीं किया?
Sir, in general, we know the mass of the whole system, but not the...
No. No. In both the case, we know M1, M2, M3. We know K1, K2, K3. उसमें कोई दिक्कत नहीं है. Hence, mass matrix is known to us. K matrix is also known to us. In one case, we have to find K inverse M. In another case, we have to find out M inverse K. Now, M inverse K will be easier. तो फिर हम M inverse K का चर्चा क्यों नहीं किया? It is a very, very interesting question. और इसका आंसर, there is a solid answer behind it.
Sir,
हाँ.
sir, as the mass will increase, our M inverse will nearly come to 0.
नहीं, ऐसा नहीं है. मास कितना इंक्रीज होगा? जितना भी होगा. ठीक है. That is not the answer. The answer is something else. Okay, I'll give the answer because I have exceeded my time. This M inverse K iteration also converge, but it converges to the highest natural frequency. And as an engineer, highest natural frequency is not that important for us. So please remember, and everything proof will come after the exam. There are two matrix iteration. One matrix iteration K inverse M. Another matrix iteration uses M inverse K. K inverse M matrix iteration converges to lowest natural frequency, will prove. And M inverse K, it converts to highest natural frequency. Now to any engineer, lowest natural frequency is more important than highest natural frequency. And that is why we were discussing K inverse M, not M inverse K. ठीक है? चलो आज यहीं पे खत्म करते हैं, unless and until you have any other question. ये मल्टी डिग्री ऑफ फ्रीडम का डिस्कशन कैसे लगा? Are you finding it interesting, श्रपा?
Yes,
हाँ
sir.
बोलना, हाँ तो बोलना ही पड़ेगा, है ना? हाँ तो बोलना ही पड़ेगा, नहीं तो मुश्किल है एग्जाम में. बट एमटेक स्टूडेंट्स, नितेश कैसे लग रहा डिस्कशन मल्टी डिग्री ऑफ फ्रीडम? भाग गया.
Yes, sir, it is good.
Then why your friends have not taken up this subject?
I don't know, sir.
You know, you very well know. Huh?
They did not want to indulge in too much in one subject.
One semester बोलो.
Yes.
One subject. But they want to get MTech degree and they want to get job, है ना?
Yes, sir.
तो ये दोनों तो contradictory है. We don't want to do hard work, but we want good package. ये कैसे होगा? मुश्किल है. Let me tell you, I am not trying to harass you. If you think I am unnecessarily making life difficult for you people, no. Today's world has become much more competitive. Unless and until you are better than others, getting a job is difficult, and surviving in a job or getting a promotion is becoming. So you have to be better than others. And to be better than others, you have to put hard work. You have to put hard work. There is no substitute. And that is why I am discussing all those difficult things. You have to prove that you know better than others. I can at least share some of emails of my past students in last 20 years. People who have gone to, who are working in industry in India and who are also gone to USA, good universities. All of them are saying that they know the subject better than most of the students in the world. They are saying. So they don't find difficulty in their higher studies or working in industry. So that should be the idea. You have to know better than other students. नहीं तो नौकरी मिलना मुश्किल है, प्रमोशन मिलना और मुश्किल है. ठीक है, चलो आज यही खत्म करते हैं. एग्जाम के बाद we will discuss after the exam. चलो खत्म, क्लास हो गया. I will not give any PPT today. As such, we have not discussed any. बोलो.
Sir, syllabus for midsem will be up to what you have taught.
Today. That's what I've said ना कि मैट्रिक्स इटरेशन में भी एक प्रॉब्लम आ सकता है.
Okay, sir.
In what manner? That I will not disclose. It can be a very small problem having some concept, or it can be a large problem as I had asked you, a 3-story building, उसका natural frequency निकालो. कुछ भी आ सकता है. So till today is the syllabus. ठीक है? I think, Srapa, this is the maximum syllabus in any subject in this semester for you. Am I correct?
Yes, sir.
Or some other subject they have taught you much more than this?
Sir, in automobile engineering also, sir, have completed.
Doble sir, बराबर है. But that doesn't have so much of mathematics.
Yes, sir.
तो वो क्या है, वो उसमें दिमाग लगाने से ज्यादा अपना नोट को यू हैव टू लोकेट कि आंसर कहाँ पे है ना. In this subject you have to apply your brain very much. So I'm happy. Automobile engineering is also a very very important subject, very very important subject. ठीक है, चलो आज यहीं पे खत्म करते हैं. Let me finish here.
Okay, sir.
You can leave. All of you can leave.